This is Part D of Section 3.9, and we're going to be talking here about the change of base formula. What this allows us to do is to convert logarithms from one base to another. Historically, this was extremely important because calculation devices, as I mentioned earlier, didn't used to have logarithms in any base other than 10, or actually one more that we'll talk about soon. So we really had to convert our logarithms in order to evaluate them. It's still a useful trick to have in your mathematical tool chest, so we'll talk about the change of base formula, even though with the log base form on the calculator, you may not use it quite as much anymore. Here's the general form of the change of base formula. It says the log base b of x is equal to the log base a of x divided by the log base a of b. A is whatever new base you want to change to. And notice the argument is still the argument on top. The old base is now the argument on the bottom. Typically, the way this was most often used was to change everything to log base 10, because those we have on our calculator and have had for a long time. So here's the base 10, or common log form. I'm just letting the base a become the base 10, meaning that, notice, I don't have to write it anymore. It's just the common log. I'd like to go ahead and I'm going to use that common log form. And let's rewrite each of our logarithms using common logs and then evaluate correct to 4 decimal places. So the log base 6 of 55, I can rewrite that as the common log of 55 divided by the common log of 6. If I grab my calculator, the log of 55 divided by the log of 6 is about I think it said 4 decimals, yes, 2.2365. Notice that's reasonable. 6 squared is 36, so we know it had to be bigger than 2, and it is. But 6 cubed is 216, and that's smaller than that, so something between 2 and 3 is reasonable. If I go to my math menu, I can also check this using that log base form that we discussed earlier. If I try the log base 6 of 55, notice I get that exact same answer. So our change of base formula is certainly accurate. Let's try it one more time. Log base 2 of 25. Let's make a guess on this one first. Let's see, 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. My 25 is in between there, right? Between 16 and 32. So my guess is the answer is going to have to be something between the 4th and the 5th powers. Let's check. Using our log base formula, I could change that to the common log of 25 divided by the common log of 2. Is about 4.6439. And notice our guess of something between 4 and 5 seems to have worked. I can also check in my math menu. I can go to that log base formula, or function, I guess I should say. And the log base 2 of 25 is, again, exactly the same thing as what we just got with our formula. All right, that brings us to the end of Section 3.9.